All right, now to what is actually section 5.5 in your non-book. Special right triangles 30, 60, 90, and 45, 45, 90. The reason they're in this section right after those other chapters I mentioned is because all 30, 60, 90 right triangles are similar by AA. But then there's something even more. They all have a certain pattern that you are going to have memorized for this class. Pattern of what the sides opposite these correspond, or these angles, what the pattern is for every single one of them. The proportion, if you will. Proportionally speaking, every 30, 60, 90 right triangle, this is what occurs. You start with the side opposite the 30-degree angle. And this side dictates all the other sides. So whatever this side is, the 60-degree side is this side times the square root of 30. So whatever this is, whatever number is on the 30-degree side, the length of it, then it's that number times the square root of 3. And then the side opposite the 90 is whatever this side is times 2. Now put little like circles there like we want to put something in there. Because what students don't get is, what do we use for numbers that we don't know? Well, they do get it, but we use letters. And every book uses something different. Some books say the letter S. So S is the side opposite the 30. So the side opposite 60 is S times the square root of 3. This is just a memorization. You're going to have this memorized. And then this side would be 2 times S. I hate S because it looks like a 5. Let's pretend it was numbers. The side opposite the 30 is 1 inch. Well, then this is 1 times the square root of 3 inches, the side opposite the 60. And this is 2 times 1, or 2 inches, the side opposite the 90. So again, whatever I put in the 30-degree side, every 30, 60, 90 has this pattern. So what do we usually do? We just put a letter that we're familiar with, like X. So then this would be X times the square root of 3, whatever that side is, times the square root of 3, and then this would just be 2 times X. And that's it. Memorize. This is your brain on math. Okay, and you're going to have it figured out, and it's not really something that you say, I don't get it. No, you just got to have it memorized and, practice it. Now, there are some questions that get a little challenging with it, but just saying. All right, 45, 45, 90. First thing you should know is, and actually 45, 45, 90, you could use the Pythagorean theorem to solve this in all cases. What you have to understand in these 30, 60, 90s, when I show you examples below here, you can't use the Pythagorean theorem because in these little tricky questions, they only give you one side, usually. They do the same with 45, 45, 90s, but just to get this over with, all 45, 45, 90s are isosceles. So if I gave you this side, you already know this side. And then how could I find this side? Well, I could just, this side squared plus this side squared equals that side squared. And I could just actually go ahead and do that. X squared plus x squared. This is going to be a little, algebra 2-ish, if you will, equals, let's just say, the hypotenuse squared. That's what this is. X squared plus x squared is 2x squared. And then, I'm sorry, that's the times there. And then how would I solve for what is the hypotenuse? You square root both sides. Square root of 2 is the square root of 2. Square root of x squared is x. Now that's the algebra 2 part. That may have been a little bit of a stretch, but that's what this side would always end up being. X times the square root of 2. All right, so what I'm saying about this is, if you ever have a 45, 45, 90, and they only give you one of the sides like this one, 4, let's say, then you could get away with just doing the Pythagorean theorem because the other side has to be 4. So you'd be fine. The only trick is when they give you the hypotenuse and not these other two sides. So I don't know, probably over and explaining it, but this is what you need to have memorized for a 45, 45, 90. That is the pattern that always takes hold in every 45, 45, 90 for the side measures. So this is where it gets tricky. You can see already, I am only given one side out of 3. So I cannot use the Pythagorean theorem in this question. I must have knowledge. I must have memorization. This first one is as Mickey Mouse as the questions can get, though. The 30-degree side, you know, I get rid of these variables for a second because I use the variable x up here to denote all the sides. You know, I'm going to use the variable x when I do this relationship again. Side opposite 30 is x. Side opposite 60 is x root 3. Side opposite 90 is 2x because this is all 30, 60, 90 relationships. Well, x equals 1. So the side opposite the 60 is 1 root 3. Side opposite the 90 is like that one I said up there, 2 times 1. So if this was a label like inches, 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 those are the answers for the missing lengths, which in this case they just use these 2 letters to explain them. AB, let's get rid of that for a second. Side opposite the 30 is supposed to be x. Side opposite 60, x root 3. Side opposite 90, 2x. Memorization, memorization, memorization. All right. Many can figure this out. Well, if this side is the 2x side, then this should be half of that because this is the x side. Or take 2x and set it equal to 9 and get 4.5. So this side equals, I'm going to get rid of that x. A is 4.5. Don't get confused with the letters. That's just what was given. I'm using these letters just to explain the relationship. All right? Or 9/2 if you like that. And then now, this is whatever this side is times the square root of 3. So it's 4.5 times the square root of 3. Just is, folks. All right, so we're going to have that memorized. All right, looking at this one, this is what I mean about this. You know, I don't even think you need that. This is already set up for the Pythagorean theorem. But those that memorize this know, and actually we'll get this question done in 1 second. Because 45, 45, 90, these sides both represent x, x. This is whatever that side is times the square root of 2. So that's how they get that done real fast. And I know I use the x as letters. That's just for my note purposes up here. Do not get confused with the letters. They said this side was 8 and this side was 8. So this is 8 root 2. All right, so that's why I did what I did. All right, all right. And then, all right, there's another 45. How do I know both of these were 45, 45, 90s? Because when they say this is y and this is y, that means these two sides are equal. That means this is isosceles. If it's isosceles, then those angles must be 45 degrees since this is 90 here, right? Okay. So what you could do is y squared plus y squared equals 28 squared, and then what? And then solve. But what I'm going to do is the way that you're kind of really, you know, supposed to approach this a little bit, you know, weird what happens here. This is x, this is x, this is x root 2. Ouch. So what I have to do is set x root 2, because this is the x root 2 side, equal to 28, so I could find out what x is, which would be what these two sides are. And again, don't get over variabled here. I'm using my little pattern that I used up in the notes there to know which sides are who. I ignore the letters given in the question that they're asking. Next thing that's weird, this is a little bit of Algebra 2 that you should be aware of, depending on what level you end up teaching in grade school. You have to divide both sides by root 2. Then you have to do this fancy little thing that's called rationalizing the denominator. So what you do is you multiply this. This is actually equal to 1. The reason I introduced another root 2 in the bottom, because root 2 times root 2 is root 4. Everyone knows the square root of 4 is 2. Freedom. All right, 28 divided by 2 is 14. So this is actually wrong. This is 14 root 2. Okay, because that's what x is, and this represents what the x side is, compared to knowing that this is the x root 2 side. And this is smaller than 28. If you would have solved through the Pythagorean theorem, you would have got 14 root 2 for y. So it would have worked. All right, let's keep plugging away. We're having fun. Of course, if this goes too fast, you always have the glory and power of reversing and stopping and, you know, taking it as slow as you want. All right, you can read the question. Stop the move if you want to. I'm moving. I'm rolling here. All right, so this is a diagonal. If this is a square, then by golly, you have a 45, 45, 90 right here. All right, finally, square 30 centimeters on each side. So find the length of the diagonal. It's done. 30 root 2. Can you see that? Centimeters. Why? Because this is the x side, this is the x side, this is the x root 2 side. Whatever this side is, the hypotenuse of that 4590 is 30 times the square root of 2, or whatever this side is times the square root of 2. So I'm done. So you do that so fast without even having